Welcome back to Math 171 Pre-Calculus Algebra. In this video, we're going to take a look at two special situations that you can encounter when dealing with partial fractions. And there is actually a third one, but it's a combination of the two, so I'm not going to deal with it separately. So the first one we'll look at is if I give you x minus 18 over x times x minus 3 squared. So what we're going to need to do with this when we have repeated roots. So we have a over x, and then we're going to have a b over x minus 3, but then what we're going to do with the third, with another fraction, we'd be tempted to do x minus 3 again, but then, okay, who knows which one it is between the b and c, and it actually turns out we wouldn't even get a solution with that. Instead, what we're going to do with the c one is we're going to put that denominator as x minus 3 squared. So now I go ahead and go through and multiply by the x times x minus 3 squared. I get x minus 18 is equal to a times x minus 3 squared plus b x times x minus 3 plus cx. And then from here, we just do the same thing that we did in the problem I did in the previous video. I'm not going to take the time to go through this again. Just know that when you have repeated terms, you have to do it for each one. And it turns out that if we had a cubed or a fourth in there, we would be doing it for each power up to the exponents there. That's there. The other special situation that you can have to deal with would be something like 3x squared plus 17x plus 14 over x minus 2 times x squared plus 2x plus 4. Now, the first thing that I would do anytime you get a quadratic is see if you can factor it. Now, in this case, it turns out you cannot factor that x squared plus 2x plus 4. So the rule for this is going to be, we're going to go ahead and do an a over x minus 2, just like we would have previously. But now we need something over x squared plus 2x plus 4. Now, if you'll remember when we did long division, that we could, when we divide by x squared plus 2x plus 4, or some other quadratic function, get something with an x in it for the remainder. So we need that here, so what we're going to have above the fraction bar is bx plus c. And now we can proceed just as we had before. And again, if we were to have a repeated factor, so like the example the book gives is 5x cubed minus 3x squared plus 7x minus 3 over x squared plus 1 squared. Well, now we need an a plus bx over x squared plus 1, I guess parentheses were technically not necessary there. And then cx plus d. I don't know why on that first one I put a plus bx. Doesn't really matter which order, so long as you know which order they're in. And this time I do need the parentheses in the denominator, x squared plus 1 squared. And again, we'll go forward as we had previously. So that concludes this video. In the next video, we're going to go on to talk about solving systems of equations into variables where one of the or more of the equations is not a linear equation.